Thank you, everyone. It's a pleasure to be here tonight. And Alan, well done on the venue. This is the most beautiful venue we've had so far, I think. It's very nice. I just wanted to give a little bit of a blurb about Spirent Communications, who is our parent company. Since you were talking about history and heritage, many of you probably don't know that Spirent Communications had a small cadre of engineers, scientists that worked on the early warning radar systems that protected Great Britain during World War II, and they were brought down to a small area in Devon for protection and safety during that time. And over the years, they eventually, in 1985, were pioneers in GPS satellite simulation. So we're really proud of that heritage, and Spirent Federal came into being 16 years ago as a proxy company so that we could develop the SASM code for the U.S. government, and our focus is now on the military government, universities, and other government-funded organizations. In that vein, as a pioneer, we are now partnering with Rockwell Collins on the new Mensa capable simulator that we will have in addition to our AES, M-Code, and SDS. So that's another partnership besides this dinner we're really proud of, is working with Rockwell Collins on that. So on that note, I would like to talk about the Products Award in Leadership in Products, and Charles Abraham and Andreas Warloe, and also shared with Javier de Salas. We're really proud of Broadcom. They were a recipient, or they are user of Spirent equipment as well, so that even makes it doubly happy to award this to them. And I won't read this explanation because, Alan, you've read it. So with that, we would like to give that award to the two of them. Are they here, or all three of them? Great. Congratulations.
Charlie.
Congratulations.
I think many of you in this room, maybe most of you, are in the business, or you're experts on perfection, making the best GPS systems. We feel like we become experts in compromise instead. If we can make a good GPS system for 10 milliamps, well, can we do it for 5? That's the next question. If we can get a half dB loss with 16 bits, well, what can you do for 10 bits, 8 bits, 7 bits, 6 bits? So it's this relentless compromise that's taken us to a point where finally we could combine 2 bands into 1 chip. And this chip is smaller, and it uses less power than our previous L1 GPS chip. So we know competition in our market is fierce. But we're excited that this actually gives us an excuse to cooperate, because this will not be adapted in phones unless all of the suppliers can support it. So we need to work together to help the phone manufacturers make the investment. They have to deal with antennas and filters for the new band, and we have to show them together that this is worthwhile. This will take GNSS to a new level, and we have to work together to do that. Now, L1 and L5 support, it does enable high-precision GPS, but it does not guarantee it. To do that takes software. We can certainly give you a starting point, and we can get great results from multipath, but to really take advantage of 2 bands, you need software, you need infrastructure. So we think that we first have to get this in phones, then we have to get the measurements out to everyone, to students, to professionals, and then we have to get the software in place. And that will enable applications that we haven't even thought about now, because no one can write sub-meter GPS applications for phones now. They can't get that. But it's this cycle. We have to get it in phones, we have to get the measurements out, and then the applications will come. And that will force GPS into lower and lower end phones. So in summary, we would like, as an industry, to work together to get dual frequency into phones. And then once that's the new standard for GNSS, we want to make these measurements available so that students can come up with clever applications and established players can monetize what they're already doing in high-end devices. Thank you.